Hello everyone, this is GEETHA from CSE department. In this lecture we will be discussing about topological sorting. Topological sorting is used for ordering vertices in a linear order. So this type of sorting will be used for scheduling problems. So to perform topological sorting, the thing you have to uh, check with the graph is the graph must be directed graph as well as acyclic graph. For one graph there may exist number of orderings. So for example, this is the graph given to you. The first thing you have to check with the graph is check whether the graph is directed graph. So in our case all the edges are directed, so this is a directed graph. The next thing you have to check is check whether the graph is acyclic graph or not. That means the graph should not form any cycle. Not only the overall graph but also the subgraphs should not form any cycle. So if it is like that, you can perform topological sort with that graph. So the question given to us is directed acyclic graph. So we can perform topological sort now. The very first step is the first thing you have to do is you have to check for the in degree. So for all the vertices, you are going to check for the in degree. In degree in sense, for example, you consider the B. For B, how many edges are coming towards B? So the edges, the arrow is pointed towards B. If it is so, that will be called as a in degree. So for B, one edge is coming towards B and two edges are leaving from B. So in degree for B will be 1. Similarly, you are going to find in degree for all the vertices. For A, you can see no arrow mark is towards A, so the in degree for A is 0. For B it is 1, for C it is 2, for D it is 2, and for E also it is 2. So in the first step you find in degree for all the vertices. The next thing you are going to do is you are going to take the vertices which is having 0 in degree. In our case A is having 0 in degree. So in step 2 you are going to remove A from the graph. So you can see here in step 2 we removed A. So when you are removing the vertex A, the corresponding edges of A also will be removed. For example, here you can see A is having 3 edges. All the 3 edges will be removed from the graph along with the vertex. So in step 2 this is how your graph will be. So for ordering purpose we wrote the A separately here. You don't want to mingle this with the graph. This one is separate and this graph is separate. So now this is how the graph will be at the step 2. So again you repeat step 1, that is you are going to find in degree for all the vertices. So B, no incoming arrow, so in degree will be 0. For C it is 1, for D it is 1, for E it is 2. So similarly, step 1 you are going to do the same thing. Whomever is having in degree 0, they will be removed from the graph. That vertex will be removed from the graph. So here B should be removed from the graph along with these two edges. So in step 3, this is how the graph will be. We removed B and the corresponding two edges. So in the ordering way, after A, B has been placed. So now again find the in degree for all the 3 vertices. So C having no in degree, that is 0 in degree. D is also 0. E is having 2. So in this case, when two vertices are having in degree 0, you will be considering it as two cases. So in case 1, either you can remove C, that means in the third step for in the ordering in the third step, either you can go with C or you can go with D. That is our wish. There is no constraint or rule for selecting this. So in case 1 they are going with C. So they removed C and the corresponding edge of C. So the ordering will be A, B, C. In case 2 you can also go with removing D because both C and D are having in degree 0. So you can choose any one. So in case 2 they removed D. So the ordering will be A, B, D. So this is how the graph will be at the next step. Either you can go with case 1 or case 2, no matter which one you follows. So in step 5, here you are going to check for the in degree. In case 1, D is having 0, E is having 1. So the next thing you will be doing is you will be removing D. So here it will become A, B, C, D. If you are going with case 2, C is having in degree 0 and E is having 1. So in next step you will be doing it as A, B, D, C. So you can check with this slide. So in case 1 it will be A, B, C, D, and finally E will be left over. So if you are removing D here, finally E will be left over. E will be having in degree at 0. So finally you are going to add up E there. Similarly, when you are removing C here, E will be having in degree 0. So finally you will be adding up the E at the last. So this is how you will be performing the topological sort. So for one particular graph, they may be having any number of ordering. So in our case, we are having two orders. In case 1, it is A, B, C, D, E. In case 2, it is A, B, D, C, E. So both the answers are right, and you can also write how many ordering of vertices are present in the given graph. So this is how topological sort will be performed. Thank you.